Hey, good afternoon, everyone. My name is Kevin Tarr. I'm an iOS engineer, and today is day 31 of Algorithms in Swift. Continued. I hinted yesterday that I had another solution to the most common element problem using the NSCountedSet, and I wanted to give you guys the solution really quickly today on this Tuesday. So here we go. Before we go, let me explain what an NSCountedSet is in case the viewers that don't know what NSCountedSet is. An NSCountedSet, much like an NSOrderedSet, is an alternative to a set, except an NSCountedSet actually keeps count for the duplicates that it removes from a set. So it still removes duplicates. It just keeps count for all the times that element, the specific element, appeared in the original array or the original set. It's pretty powerful. It's from Objective C. It's very, very good for keeping count of appearances, much like a dictionary can be used, like we used yesterday, to keep account for appearances. And it's very effective in solving this problem. Again, it's not as verbose as previous solutions, not previous solutions I've done, but other solutions I've seen with this problem. It solves it in one for loop, and it's a pretty concise amount of code. So, without further ado, let's begin. So, first, I'm going to create a guard statement just to take care of edge cases. Um, Return that. Then I'm going to create NSCountedSet. I'm going to call it counterset equals NSCountedSet array nums. Okay, simple as that. Then I'm going to sort the set, because what we're going to do here is we're going to sort the set in descending order so that all the elements that appear the most times are at the front of the array. Okay, so the way we do that is we create a sorted set equals counterset dot all objects. We force cast it to of type integer array. Then we sort, wrap a closure around this, counterset dot count for element is greater than. So all we do is reverse the greater than less than sign to make it descending order for the set. Okay. Then for here twice. Sorry. Then we create a variable, and now yeah, I think that's good. Cool. So now we create a variable. Those parentheses always kill me. So now we create a variable of our most to capture the most appearances in the array. The reason why we put this in an array is to take account for ties. If the rules we were given said, hey, just return the element that appears the most times, and there won't be any ties, and we just return an integer, regular integer. But since it doesn't say that, we have to actually take ties for. We have to take accountability for ties. So most appearances, we do sort of set that remove first and that returns the first item while removing it. And then we for loop through the set, sort of set. If counted set that count for number equals counted set dot count for most appearances dot first, then most appearances append number, else return most appearances. And that's how we solve it. What we're doing in the if statement is we're comparing the current number that we're for looping over and the amount of times it's appeared to the maximum amount of times that any number has appeared in the array, because concise has gotten that for us. And in its first element, we remove the first element from the sorted set. That was the element, that's the number that appeared the most. So we take the count for that number and we ask if any number after that is any number after that, if their appearances are equal to that number's appearances. If it's equal to that, then we have a tie. So we keep adding that to most appearances and keep adding that to the array. The moment we find a number that does not equal that, because we're going descending order, it will be less than that, then we know that we can instantly return an exit out of the function, because there's no numbers left in the array that equal the maximum amount of times of an appearance within the array. So that's safe for us to do, and that makes it clean and easy for us to not use as much space, not use as much time for looping through the entire array. We can exit out immediately once we just find all the ties, or if better yet, if we find that that was the only number, the most appearances, the first number was the only number that was equated to the maximum amount of times, and there was no other ties at all. And that makes it clean and effective. So here so now we can try to test this now, okay? And we can actually do our first test case. 1, 2. And we should get 2. Yep, boom. Okay, so let's do 4, 1, 2, 3, 4. 4, yep. And let's do 7 and 8. Great, fantastic. So this works. This solves our problem. I think that it is short, concise. I think that it is straightforward and expressive. And I think that it is a very good use of using NSCountedSet, again, another Objective-C collection type, to solve this problem and really be effective in doing this in a very, very short amount of time in terms of time complexity. So guys, let me know what you think in the comments. Let me know if you have another solution to this problem that you'd like to share. And happy Tuesday. Bye.